Hello, good afternoon. Yep. Okay, so uh, if you have any submission problem, I will explain later because I'm going to talk about it. So welcome to today's lab. This is week 3 and lab 2. And I think it is about the due of lab 1, right? So today's content will be the report submission at first. So we will go through all the important points about how to do the submission of our report. Like I will mention all the important stuff to you, and I will also show you how to do the submission. And then we will go through the week 2 content because before we do the lab 2, we may need to know something like HTTP and DNS stuff, and we will have a quick look of it. And then we will do the lab 2 like from question to question. And then after that will be a question and answer if you have any doubts. So let's go to the first part. Let's do the report submission. So to submit the lab is pretty simple and easy, but you may have some like question about it because you may not know what should I submit and like is there any format about it. The answer is there is no uniform format for that. So you can use your own format, but just make sure you follow these 3 rules. The first one is make it clear, which means you just answer the question directly. And in this point, you should also be aware of that you don't need to copy and paste the question because we already know what is the question. So just simply specify what is the question, like the question 1, and then you answer directly. And just make it clear. Do not copy and paste all the questions in your report. And the next one is show your effort. This means if you are not sure or you have no idea how to do this question, just answer it anyway, and also show your research. Like you can say, I searched in the internet and have a look on the slides, and this is what I think. Maybe your answer is not true, but just show your efforts, then you can still get some points. And for the assignment, it's the same. So for example, at the last question of today's lab is a programming stuff, right? So you just write the application anyway. If it doesn't work, just make it like an application. And like if it doesn't work, just show it to us. Like show us your efforts. You can still get some points, I guess. And the last one is the format, just to make your report like looks beautiful. It's pretty simple and straightforward. Just set the font and the images and tables in the same format, no matter what is the font it is. Just make the like format consistent. So it's not pretty hard, right? Just a normal report. But I think the most difficult thing is to make the submission because some of the students may made a mistake. They submit a RAR file because they are using their Windows to zip their reports, which cannot be opened in the WeLab. Because you should know that we are marking your assignment in the WeLab environment, which means you should always test it in the WeLab after you do the submission. You can do the submission via this web CMS, like in here, should be in here. You can do the submission via the labs, I think. Let's have a look. The submission is in here, right? Here are the instruction of how to do the submission. You can also submit it via the web CMS in somewhere, I think. Maybe in here, you can try by yourself, but I recommend you to do it in the WeLab. So these are the instructions. It's pretty easy and straightforward. All you need to do is just copy this one, right? Copy this command and go to the WeLab. For example, I will make an example for that. Let me just create a document. For example, this is my report. And what should I do to do the submission? You just go back to the web page and just follow step by step. Put all your files into a directory called lab1, right? So let's just call this one lab1. So change the name of folder first. And then go to the second one, just copy this command and go to the terminal. Just run a terminal in the same folder, right? You can also use the ls command to check if you have the folder in here or not. Make sure you have the same folder in here, and then just paste the command. Oh, sorry. I paste it. Okay, I cannot paste it. Just type it anyway. So it's tarcvf, tarcvf, and the next one is the name of the folder, the zip file. So it's lab1.tar, and the lab1 is the folder name. You can have a double check in here. So just simply copy the command and just type it. Okay, so this one failed because I exceed my disk quota because I used too much in my own WeLab, but you can try it. I generated a file anyway. So you can have a check if this one is correct or not. You can just simply open it. And you can do the submission anyway after that. Just use the command give cs3331 lab1 and lab1 top. So you just type give cs3331 and lab1 have a double check 3331 lab1 tar, make it capital. And in here, because I save it, it's not in capital, so it's small one. Just make the file name is correct, and then do the submission. Okay, so that's it. Yeah, because I create my own stuff as an empty file, because this report is an empty file. So you can put your own reports into this folder and you should not have this problem. So that's how we do the submission. Should be pretty easy, right? Just follow the instruction in here. Just follow these 4 steps and make sure you have a double check after that. So you can open the TAR file in your own WeLab and have a double check. You can also check the size. It should not be 0 bytes, right? So if you submit an invalid file, you may get 0 marks, right? So don't waste your time in the last step. But of course, if you made a mistake and you realize that, please send me an email so we can fix this problem. Okay, let me check if we have any question here. The first question is, do I need to submit a folder has rumpin.sh? No, you don't need to. Just attach the files we need. Is it necessary to tar the file? Yes, it is. You have to tar the file. How about those outcomes from rumpin.sh? Do we need to submit them all? Yes, you do, because we require you to do the submission of that generated file in the report, right? So you can have a check in here what to submit. Basically, we require you to contain all the file generated in here and do the submission. Do I need to attach all the images within the report? I think you don't need to if it doesn't require you to do like attach it. For example, the output of the exercise 3 or exercise 2. So the trace route command, you may want to show some screenshots from this part, right? So you can just simply put it into your report and you don't need to do the submission with it because we can see it in your report. Another thing is you need to make sure the picture is clear in your report. Just have a double check in your WeLab because in some PDF file, we cannot see the picture or images clearly. It's pretty blurry and we cannot see anything. Just have a double check of it. My TAR file is 7 megabytes. Maybe you put too much images into a report. So just follow the rules in here, make it clear. So just answer the question directly and do not put a lot of things for one question. So every question should be answered in a few sentences. So try to delete some images which is not necessary. Or try to merge some images. Like you can merge 2 images into one. And do not make your report very, very long. Yeah, and that's it. Even it's oversized, if you can open and if you can open it in the WeLab, that should be fine, I think. Just have a double check if you can download the submission again. I think it's okay. Okay, so let's have a look of today's content. Let's just have a quick look of the HTTP stuff about what is the request and response and the status code and headers and how can we understand it. This is very important before we do the lab2. So we just simply go to the lecture slides and just have a quick look of it. So application layer should be in here. Okay, so we want to have a check of HTTP stuff. So HTTP stuff is pretty simple and straightforward, right? Because we are using it every day. So in here, we talk about the version of the HTTP. Usually we are using HTTP 1.1 on the communication. This is not the important thing for today. Today, we want to have a check of the headers. So don't worry too much about the content if you feel a little bit complex, but just get this one clear. Request. So you can imagine HTTP is a kind of language. So what do I mean by language? Like, let me open my whiteboard. For example, you can consider this is your your PC, and you are trying to communicate with the server. So you are trying to communicate with the server. So if you want to get a website or get any kind of content from the server, so what should you do? What should you then send to the server? So for this kind of thing, we invent the HTTP for that, which means we can use the HTTP as our language, so the PC and server can understand each other. It's pretty simple and straightforward. For example, in here, let me just add an X. For example, we want to visit the main page of Google. So we will send your main page .html. And then the server will send another response to us, and will says here is my main page .html. So that's how it works, and then we call it HTTP. So, but of course, it's not in plain text. It is in some kind of format. So let's have a look. What kind of format is this? So we call the first one request because it's from our PC. Request because this one is from our PC to the server. And we call the second one, which is the response, and which is from the server to our PC. So you know what is the difference between the request and response right now. So we can have a check of the request first, because the request is from our computer to the server. So it should be indicate what kind of content do we need and the details of it. So you can see here are the content we sent to the server. The first line indicates what is the method are we using. Usually we can use get, post, and put or other methods. And we will talk about it later because this part is also very important. And in here, you can see the index.html. This one usually indicates which part or which file do we need. So in here, we are requesting the index.html. Usually it is the main page. And the next part is the HTTP version, is HTTP 1.1. And these two symbols indicate we are going to have a new line. So it's just a symbol to indicate a new line. So in this part, we call it headers. So the headers will have more details about the thing, like about the request or the response. Then you can check more details about it, like what is the host, basically what is the URL we are requesting for, and what is the user agent, so, which means what is the browser of us, right? And other thing, you can check it by yourself. It's not very hard to understand. And at the end of the header, we will have another one, right? These two symbols to indicate it is the end of the header. So that's the request. And let's have a look. What is the response? It's just very similar, like this. Here the response. So the response is from the server side to our own computer. So it should indicate like what is the response content, right? And it may contain some data because we are usually trying to get in some data from the server side. So at the end, you can see there are lots of data. But at the top line, you can also see the version of HTTP. And this number 200 and the OK. So we call it status code. This one is also very important because it identifies what is the result of this response. And there are some metadata, we also call it headers, right? It just describe what is this response. including the date and the server and other useful information. So that's the response and request. And so just like we learn what kind of language is this, right? Just like we are trying to talk in English, and now we are trying to talk in HTTP. And here are some translation of the status code. And this one is very important. Just try to memorize it. I will give you a small trick on that. It's pretty easy and straightforward to remember this part. If you encounter something start by 2 something, which means success. For example, 201, 202, 203 is also indicating kind of success. And 303XX will indicating redirection. So it will always ask you to jump to somewhere or something like that. For example, the 302 will also send you a new URL and ask you to jump to another website or another URL. And the 4XX will always indicating the, this one should be the client side error. For example, the bad request. So you didn't send the request, which in the normal format. And 404, which means there is no file that you requested. And next part is 5XX, which means server side error. So after you have a look of the status code starting from 5, which means the server side has some kind of error, then it's not your fault. Okay, so that's all the thing I want to mention here. Just some tricks to recognize the status code. Oh, sorry. Okay. So I should remove all the thing. And let's have a check. I think that's enough should be today for today to do the lab 2. If you have any trouble with the content in here, just let me know so I can explain more. So let's have a look of the lab 2 content right now. For the exercise 1 and 2, so we'll do the exercise 1 and 2 at first. The exercise 1 and exercise 2 is not required to be included in your report. So just have a look. Do not put it into your report. You can try to do it by yourself. And let's have a look of first one. So what is the Telnet? So Telnet is a kind of protocol that allows you to remotely control another computer or fetch some information from another server. Like this one, we can use the terminal in Windows and type this one, right? So let's just do this one. Let's just type it. We can just type the same stuff, vision.ucla.edu and 80 indicating the port number. So the HTTP server always use the 80 as their port number. So this one is the default port number. And we type, oh, sorry, I cannot use it because there's some error in here. But we can try to use the VLab environment to do it. Telnet and vision ucla.edu 80. Okay, so you can see we can run it in the VLab. And now we are connected to the ucla.edu. So what should we do to do the communication? We just establish the communication, but what should we do after that? we can just request something, right? So we can just type these two rows, which is get HTTP 1.1. Just simply send a request, right? That's what we learned in here. Sorry, let me put a screenshot in here. And then we do another screenshot in here. Then we just run it one by one. We just type the, oh, sorry, it's closed because I took too long to get it. So let's just type the request again, HTTP 1.1 and HOST. Then you can see we receive a lot of stuff, right, in here. So we can scroll out a little bit. Then you can see after we send this request, we will get a response. That's what we learned before, right? So you can see the response contain the first line, which is indicating the HTTP version. And of course, the status code, which means 2XX, right? Which means okay, we successfully get a response. And what is the time? And of course, the other information from the response. And after that, it's the data, right? You can see the data is very, very long in here and contain a lot of like head or body or stuff. We call this one HTML file. So this file can be easily understood by our Chrome, by our browser. If we read it in our browser, it should be a normal web page, right? But if we read it in like directly with this kind of file, it's a little bit hard to have a look of the content inside. So if we can put this kind of stuff into our browser and read it, the HTML format is very easy and very easy to understand. So you don't need to worry about too much about it. I reckon you should take like 15 minutes to have a look of it. Like what's the format? So what is the P label? What is the image labels like that? So it's very simple and basic stuff in computer science. So that's the thing. How can we do the Telnet protocol? So you can do it by yourself. So let's go to the next one. This one is about the cookies. So we can have a check of the google.com.au. So instead to running this one in the Telnet, we just simply run it in our own computer in the browser. So you can have a check what is the cookies when we visit the website. So I just visit a website right now. So in here, you cannot see any like cookie stuff, right? So I can use this kind of thing to have a look of the cookies. Like in here, you can see the cookies for google.com, including these all kind of values. It will get my SSID and get my other stuff. It's quite scary, right? It will get my Wi-Fi content and Wi-Fi details in here. So how can you check without this kind of add-ons? You can just simply press the F12 button. Yep, then you can see this kind of stuff, right? Then you just refresh this page. You can see the like what is the traffic between you and the Google server. And of course, in the response, you can also have a check. Is there any cookies inside? Let me check if I can find the cookies. Should be in here. in here, you can see set cookies. So when I send the request to the Google server asking for the index, the main page of Google, and then you will have the response containing a set cookies command inside the headers, which means they want us to remember this kind of stuff into our site. And next time when we try to send a new content, let's say when we try to search something in here, then in the new request, we will attach the cookies they gave us. Let me try to find it. It's a bit hard to find it, right? Request headers in here. So in here, we have the cookies, right? You can see this part. We are sending the cookies with our new request to the Google site. So the Google server can easily understand us which computer is this. So let me just make it clear. Let me draw something here. So in here, the same stuff. In here, when we send a request, and the server will reply a response and plus and cookies plus a cookies into here. And next time, when we try to send a new request, let's say new request and plus and the server into the server side. So what does this mean? Do you have any idea? Like when we send a new request, maybe another content kind of request with the cookies they gave us. So what can server do in this time? Any idea? Yes, exactly. So the server will see, like, so the server will say, oh, it is machine. It is, let's say, it's me instead of other person. For example, because we have lots of computer connecting to the same server, connecting to the Google. So how could Google know who is this? Usually they are using cookies to do the verification. So every time I attach my own cookies, and of course, they can also know my IP address and other content, and they will combine them together to do the verification. So the server can just use the cookies to verify which person is this from the request. So this kind of thing will allow us to do the login and log out stuff. Okay, so that's the thing I want to say. Exercise 1 and 2, and let's do the 3. So this one is pretty simple and straightforward. I want to mention is how to run the Wireshark at first. So in here, in the WeLab, just run the program Wireshark and type it. Then you can open it. And in the Wireshark, you may want to open some kind of file, right? So let's just download the file first. Web browser. And this one. And lab2. Okay, so download this two file, the trace file. Just download it and just simply click it. See if we can open it. Maybe not. Okay, so yeah, because I exceed my quota. I'm sorry about that, but let me try to figure out a way to open it in here. Maybe I need to delete something. Let me try to delete. Okay, let me try again. Hope it's working right now. Okay, so now we got it. So you can see we have already downloaded it. Just simply double click it, then you can open it. In here, I just want to introduce the basic operation of Wireshark. Open the file is pretty easy, right? You just double click it, or you can drag the file into the Wireshark. And after we open this one, then you can see lots of content inside. You can see this part can show you how much packets do we have inside the trace file. You can see there are 17 17 packets inside the single trace file. And you can also check what is the time and what is the IP address of the source and destination, and what is the protocol of it. And of course, the data size and some critical information about it. Because we just learned the HTTP now, right? So we can just simply apply a filter in here by typing the protocol name like HTTP. Then we can just remove all of the other protocol from the windows. And then you can click one of the packets here. And then here are more details about it. So in this part, you can check in which layer we have which kind of messages, right? So we only care about the HTTP part right now. And in the future, you may have a check of the TCP thing, but today we just have a check of the HTTP stuff. So in here, you can see that's the thing we are familiar, right? Just the request, the header of request, the get of this kind of HTML with the version 1.1, and the headers are following. And that's it. And in the next part, you can see here are the raw data of this request. So just ignore it. And you can also check another packet. This should be the response, right? You can see the response 200 OK and the headers of it. And you can just play around with it and check another one. This is also a request. So what is the request? It's requesting the favicon.ico. So do you know what is this? So usually we we visit a website, we will send two requests. The first request is request the web page itself. And the second request is for the ICO, so which means icon. Do you know like where is the icon for the website? For example, our web CMS, this website. You can check in here. You can open the F12 and try to refresh. You can see we send the first request, right? To request this web page. And then second request is requesting the ICO file. So what is the file? Maybe you saw this one already. So here are the response, right? It's a ship. So you can see the icon is just in here, in the title. So we are requesting for the icon. And in the response, it says 404 not found because not every website have the icon. This website doesn't have the icon. So that's the whole conversation we want to understand. I think it's pretty easy and straightforward after you can use the Wireshark, right? And if you can easily understand the request and the response, it should not be a problem for you. And then we can go to the next one. This one, the using the Wireshark to do the same thing again, but maybe different conversation. So we just open the VLab and download another file and have a check. So we download the trace file too and open it. And again, we apply a filter first. Just type the HTTP because we only care about the HTTP conversation. So in here, you can see there are one request and one response, another request, another response. So let's just have a look at it one by one. The first one, he asked, we want to get the web page of this one, right? So it's pretty simple and straightforward. We just simply send a request to this website. And then what is the response? It says 200 OK. 200 OK. And do we have any other thing that we want to pay attention of? Like what is the last modified and E tag, right? It contains some information about last modified and the E tag in here. So let's have a look of last modified. We can see the date of this request is like 2003, many years ago, 19 years ago. And what is this? So there are 2 dates in the headers. Do you know what is the difference between them? Like what is the difference between date and last modified? So you can see they are slightly different in here, in the second, right? The last modified is 50 seconds before the date. Do you know what's the meaning of that? And there's an E tag with this. So the last modifier indicates when did we change this file? Yeah. Is it cached at this time? No, but you're close to it. So the date indicates when did we have the conversation? When do we have this response from the server to our own PC, right? And the last modifier indicates when did we modify the file we requested. So why should we have this kind of stuff inside of our header? And I will show you right now, and you can answer the question. So we can have a check of the second one. The second request, you can see it's exactly the same as the first request. We are requesting the same stuff, right? We are requesting the same page, but this time we have something inside in our header. You can see if modified things and if non-match, these two kind of thing is very important here. I will take a screenshot. You can see these two stuff in the second request, which is not exist in the first request. You can see the first request does not have this header, right? Because the server side send us this information in the first response, then we put it into our second request. And let me show you why. For example, at the same stuff, we are requesting for the HTML page, the page HTML. We are requesting for the main page of the server. And they gave us the main page, right? And then we send a new request. Give us the main page again. We send a new request. Says that we need to have the main page again because we want to check if we have any new things on it, and we will plus the like e tag and modify date, right? So because we attach this kind of stuff to the server, and the server will know maybe he already got the previous version, and then I can check. The server will check if we have newer version of main page, right? So in this case, we don't have the new version, and if no, then reply 304, right? You can see the 304 not modified, which means no new things. So that's the whole conversation. So firstly, we send the request to get the main page. And then we request it again, just give us the main page again. We need to check, do we have any kind of new stuff on the main page? And the server says, no, there's no new things. So just keep the old version. So do you have any idea why should we do all this kind of stuff like in the request and response? Why should we just simply reply the main page by like without checking it? So we are doing all this kind of stuff just to check if we have new version or not. Like, isn't it a waste of time or waste of computation? Yeah, because you can see it is not on our own computer connecting to the server. If we have millions of computers connecting to the same server, like Google, the server will be very busy by replying the same content, right? So they invent this kind of stuff just for saving the internet traffic. So you can see what is the length between these two responses. So the first response containing the main page is 739, and the second one is 243. So it reduced the traffic in our internet, and of course, save the energy in the server side. So for one request and response, maybe it's just a little bit saving, but for a huge amount of like request and response, we can save it a lot. So let me just share screen. So I think now you can get the whole idea for that. For 3 and 4, let's have a look of the exercise 5 right now. Yeah, if you have any trouble with the question, just let me know. But now you got the idea, why should we use the e tag and if modified, right? We just need to have a check if they have the new version of the same page. And this part is the exercise 5, the ping client. So we are requiring to do some programming stuff. So in here, I will show you how to run the stuff. at first. So all you need to do is follow my steps. Let me just download the file at first. We need to download the server, the Java. So if you have no idea how to like do the programming in Java, there's no problem. You can just simply run it. You don't need to know how to do programming in Java. So what do we need to do is just download at first, and then we just copy this part. I will show you. In here, you can see the instructions. Let me just compile it first. Java C and ping server, and press enter. Then you can see we create new file. Then we run it with Java and ping server, and with the port number. So in here, a lot of students just type this one, and you get an exception here because the port number, you need to change it to a value, let's say 7777. So we are running our server into this port number. And then you can see there is no output, right? So what should we do next? This means our server is running right now, and which is good, but we need to have some output in here. Then we are required to write a program that can connecting to this ping server. So what should we do? We should create a new file. Let's say empty file client.py. So in here, I will show you how to do the Python version. We can open it with, I don't know, maybe Spider. Spider is easier to use. Let me just run the spyd. Okay. Oh, sorry. Okay, so this is our client.py. Let's try to run it first, see if it's working or not. And run it, then you can see it can print something in here. So we can start programming. In here, what should we know is how to use the socket. So SOCKET, we are using this stuff to do the programming. Let me think, what's the first thing do we need to do in here? I think it's in here, it should be in here. So in here, we are going to send some stuff to the server. You can go through all the content in here, but should be this kind of stuff, right? We are required to send this kind of information to the server. So let's just try to write a program that can send this kind of stuff. Let me open it right now. Okay, so let's try to send something to here. I think firstly, we need to put the address. Address is 127.0.0.1, which is the local host. And the port number is 7777 because we set the port number in here. Let me show you. So why is 7777? That's because we run the server in this port number, right? So you can also set it as another number. That's fine. And what's next is we are going to create an object that we can connect to the server. So we are init an object that can send TCP packets. So we call it socket. and socket.socket, and we need to put some parameters inside. So it's socket dot, what is that? It's AF inet. I think it's this one, and socket dot sock. Oh, this one is UDP. We should send the UDP. Let me try to send the UDP first and see if it's working, because we are doing the ping command, right? Ping use UDP. And we can also send a message, because we want to have some like kind of message to send. We can send hello world. And what's next is to send right now. So sock.send to, and we will encode the message to this address. Yep. And then we can close this socket. So in here, message content here, send to the server in here. So in here, we are going to initialize a socket object and then send a message to the server, and then we close it. So we try to run it. You can see when we run it, there is no output, right? But in the server side, you can see we do send something into our server side, right? So let's just run it again to have a double check. You can see hello world in here already, and we can change this one and run it. You can see the output is different. So how can we get a response? Because the server says it send a reply to us. So we need to check what is the reply. So we add something here. Receive any the reply. So to receive the reply should be sock.recv and 1024, which is the buffer size. And yep, and should be enough. Yeah, and we can call it the response is this one, and print response from the server. So decode, because we may need to decode the response. Let me try to run it. I'm not sure if it's working or not. Okay, then you can see response from the server. It says hello Ray, right? It does work. And let's run it again. Response from the server, it says hello Ray. And let's try to modify this one. Hello Ray. You can see. So every time the server replying us with the same content that we send to the server. So you just keep running, keep running, keep running. Every time it's the same. Okay. Okay, so in this time, the server says reply not sent, because there is a random function inside the server. It may not reply the response to us. And in here, you can see we stopped. We cannot run it anymore. We just keep waiting here, right? So what should we do to add a timeout and figure out this question, figure out this problem? You can see my client stuck in here. So I need to close it. So I close it. So in order to avoid this kind of stuff, we may need to set, so it's sort or set timer or something. Let me check. Set timeout. I'm not pretty sure, but let's try. Set timeout. Let's set a timeout as 1 second. Timeout 1 sec. Which means if we didn't hear the server back within 1 second, then we will raise an exception. Let's run it again. Reply send, no problem. And no problem. Until we, in here, you can see, we figure out a timeout event, right? But in here, you client crashed because we raised an timeout exception here. So what should we do to catch this kind of stuff? So we can do the try and accept. And yeah, you may need to add the type of exception here. You may need to add the timeout exception here, right? You do this by yourself. If you have no idea how to do the try and accept syntax, you may also check out the syntax of this at first. And just make sure you add something here. Catch it. Otherwise, you will catch every exception. So in here, we can just simply print no response from the server side. Okay. Okay, so let's try to run it this time. And let's make a for loop, and then we can, so we make a for loop for I in range, let's say 10 times. And then we run it. And then we, of course, attach the number of times. Now this time we will run 10 times in a row and see what's the output. You can see we send 10 times and there are 2 times it's failed. Sorry, I didn't put the F in here. Let's run it again. So you can see 0 got a response and the 4th time doesn't get a response, right? Okay, so your task is to add more code in here. So to do add more code in here, calculate the RTT. So this program is not complete. You need to do something here, just add more code in here, and then you need to calculate what is the RTT, which means how long does it take to receive the response, right? So I complete 80% of this program for you, just in case you have no idea how to do it. But I still leave something for you to do it. You need to, maybe you need to understand how to do the socket at first. So this line, don't worry too much. We just simply copy and paste. We don't need to change it. But maybe this part, you need to change. And of course, the ADDR, this part you also need to change, right? Because when we run the client, we are going to run it like this. So Python 3 is like this, which means we are going to run the Python in the terminal. So we will, the Python 3 client, we will attach the 127.0.0.1 and the 7777 in here, right? But my program is not complete. For example, I changed the 7777 to 8888. It will still working, right? Because I hard code my address in here. You need to accept the address from the user input in the terminal. So do you know how to do it? So you should also use the SYS. And then you can print something SYS the ARGV, like user inputs parameters is this kind of stuff. Let me just type it for you. And then you can run it again. You can see we add this kind of stuff in here. And when we run this stuff, you can see what is the user input in here, right? So you need to read these two stuff into your own program. So you do. As ADDR. So when I test your program, I will not test in this port number. Just be aware of that. I may test in another port number. If you fail to do that, you may lose the marks. Just be aware of this. You need to accept the user input, like this one. For example, if I am running the client and the server in different port number, so this is the server. I am running in another one, let's 8888. It's running in different port number. And then in the server side, I will also run the client like this, right? And it will be timeout for every request because I hard coded my program into the port 7777 in here, right? So I need to change it to AAA in here. But of course, in your program, you need to do it via the sys.argv. You need to do the investigation by yourself. Okay, so that's basically all the thing I want to mention here. So if you have any trouble, just let me know. And I will also share the stuff to you into the GitHub link. So the exercise 5, we go through the socket programming basics. I explain the code to you line by line. And yeah, I can take a screenshot because I don't want you to copy my code directly. I will upload the screenshot to you. Okay, so we can go to here. You can also have a screenshot if you want. And how to run the scripts. Maybe I just put it into the slides, like in here. And how to run the scripts. I have shown you how to run the script of the server and client, right? So the server is Java, it's not Py. But the client, you can do it in Java or you can do in Python. It's the same, no problem. Okay, so that's the thing I want to mention here. Let's go to the next page. What is the, I will upload the slides and the recording. And if in the future I have some demo codes, I will also upload into the same link, which is in here. I will share the link to you so you can get the slide easily. This is the slides from last week. And so, yeah, if you feel a little bit confused and have no idea what I'm saying about this code, like you feel dizzy about this code, don't worry about it. Just spend, let's say, 2 hours on this code, because you can see it's only 31 lines, including the comments. You don't need to worry too much. Just read it line by line and try to understand it. And of course, if you can check out the video again, that would be great. And of course, you can also Google it. It's just very simple and basic. And of course, read the instructions of the slide, of the, what is that? The questions, the examples in this part. So firstly, read all the contents. After this part, just try to understand how the ping server works and how the client communicates with the ping server. And then just try to run my code. Just type the same code as mine and try to run it. And if you have the same output, and then play with it by adding more codes into this program. So I have specified what you need to do in here, right? You need to change the ARGV so you can accept the user input. And you also need to add more code after the try so you can calculate the RTT. And that's it. For calculating the RTT, are we supposed to count the time span that we spend in the message to give this response and time to, yes. Or are we supposed to calculate the time that we send the message plus the time that it responds the same message? It's a bit long. Give me a sec. Yeah, I didn't get the point. Can you like explain it? Yeah, of course. You can speak.
Sorry, can you hear me?
Yes.
So what I mean is that, like, for this specific program, to calculate the RTT, are we calculating the time that when we send the message packet to the server and times 2, or are we adding the time that we send the packet to the server and the time that server responds with the same message? Like, are we calculating the time from line 16 to line 27, or are we calculating the time that spans from line 16 and just times 2?
To which part? 16 to...
Well, let me see. I think it's to I'm not sure to
Okay, no problem. I will explain it to you. Okay, so before, maybe we can draw a map and draw a conversation stuff. So can we delete? Yes. So this is the client of UI, and this is the server dot Java, and they communicate with each other. So the first thing happening here is we send a message, right? Then yeah, should be like in here. The first step. And the second step is from here, the Java server to reply the same message. So we need to calculate the RTT. So before we send the stuff, then we need to calculate the time. So we will put 2 timers, right? And put one here and one in here. So I will call this one T1 and this to T2, which means when we send, before we send the message, we will have a timer 1. And then after we send it, and then we get a response. After we get a response, we will have a T2. Then we use the T2 minus T1 equal to RTT. So you can see we will have the T1 before we send the message and have the T2 after we receive the reply. Is that okay?
Yeah, so basically we can just test the cases where the server successfully replies.
Yes. So where did we send the message? It's in here, right? You're right.
Yeah,
We send it here.
seems
Yeah, so maybe we need to have a T1 here. And when did we receive it? We receive it here, right?
okay.
We may have a T2 here. And the RTT will equal to T2 minus T1. And just print it out.
And we need to times 2, right? Because it's like,
So
oh no,
why
we don't.
do you need to
We don't
time?
need to.
It's already like the round trip time already.
Yeah, I know. It's already like the packet has been to server and come back from the server.
Yes.
Yeah.
And another thing you need to do is to calculate what is the calculate average. Sorry. Okay. So you have another thing to do is to calculate what is the average RTT here. Just follow the specification. So it's not pretty hard. Just try to play around with it, and then you should be able to handle it.
Yeah. Thank you. I got it now.
Yep. So which part? Okay, I think I've already answered it. Just feel free to ask me any question. And I will upload this all the stuff into the GitHub link. And if you have no doubts, feel free to leave at any time. But yeah, if you have any trouble, you can stay there until the end. And thanks for coming today. Okay, see you. Yeah, the recording will be available at the end of the day. I will stop the recording. So if you want to share your screen, you can do it.